Hey there, Mustangs. Welcome back. Uh, Today we're going to be working on combinations of functions. I got to tell you though, before I get started, I had a pretty rough day today. Um, my wife, she told me to quit. She goes, quit ruining my birthday, and I go, I didn't even know it was your birthday. All right. Anyways, so let's get started here. Combinations of functions. So first, the four basic ones that we're going to be looking at are when we take and we add functions together, subtract them, multiply them, and divide them. Only one of them has some unique stuff that happens with it, and we're going to talk about that in a moment. Okay. So when we're talking about f of x plus g of x, what we're doing is we're taking functions and we're adding them together. So I'm going to do this one in red, and we're going to do this one in blue. And hereafter, I'm going to use blue and red just to decipher between which ones are which. Okay. So in our first one here, we're going to do f of g. So that means we're going to take, oh gosh, hang on. We're going to take f of g, f of x, and we're going to put that in for each one of these spots here in the problems. And then we're going to take g of x and we're going to put it in for each of these spots within the problems. Okay. So for our f of x function, we're going to have 2x minus 3. I don't know what just happened there. 2x minus 3 for the f of x. We're going to do the same thing for the other one. So 2x minus 3 for this part, and 2x minus 3 for this part, and 2x minus 3 for this last part. Okay. Notice I just really quickly just put in for each one of our f of x portions of the function. So now what we're doing is the operation that's stated, which is add, subtract, multiply, and divide. And we're going to put in the g of x portion of our function, which is x squared minus 1, x squared minus 1, x squared minus 1, and finally x squared minus 1. For the first problem that we have, where we're doing the addition, it's just combining like terms. Real simple, nothing crazy. We're just combining like terms. So it would be x squared plus 2x, and then we have a negative 3 and a negative 1, so we end up with a negative 4 here. Okay. With the f of x minus g of x, again, just combine like terms, but realize that because we have a minus here, that minus will get distributed to everything to the right of it. So we end up with a negative x squared, a positive 2x, and then that's actually going to be a positive 1 right there from distributing the negative to the positive. So negative 3 plus 1 gives us a negative 2 for our final answer there. Okay. Multiplying these together, we're going to go ahead and make the rainbow. All right. Also known as distribution, but I call it like the rainbow. Or I'm sorry, not the rainbow, the moon. I don't know why I said rainbow. The moon. The moon looks like this. So we're going to have this, and this, and this, and this. And it looks kind of like a crescent moon almost. So that's the first, outside, inside, last. But we should have 4 terms when we multiply it out. So we're going to have x cubed, minus 3x squared, minus 2x, and plus 3. Okay? Again, adding, subtracting, multiplying, real easy. The dividing one has something else that we have to state. First of all, if we could reduce it, let's reduce it. But the other portion that we have to do is, because we have a fraction, anytime we have a fraction, if you remember fractions and square roots, we have to talk about the domain restrictions that take place in the problems here. So in the instance where we look at this one, we've got a denominator, there's a restriction here. X squared minus 1 cannot equal 0. Not allowed. That means that x squared cannot equal 1, and if I took the square root, x cannot equal 1 or negative 1. So that's the additional portion of this that we have to state over here, is that x cannot equal 1 or negative 1. It creates that restriction, the domain restrictions for us. Okay? All right, so the domain of arithmetic combination of functions f and g consists of all real numbers that are blank to the domain of f and g in the case of the quotient. There's further restriction that g of x cannot equal 0, and that f and g consists of all real numbers that are in part of the domain, or no, inclusive to the domain of f and g in the case of the quotient f of x divided by g of x. There is a further restriction that g of x cannot equal 0, though. Okay. So when we look at these right here, that's just the definitions, which we just went through. Okay. So if I was to say find the sum of the functions, you have to find first what it's talking about here. So in this case, it's saying take f and add g to the function. So we're adding the two functions together. Now there's technically two ways that we can do this. Okay, I'm going to show you both ways. The first way is taking g of x and actually adding it to f of x. So that means we have f of x, we're going to add g of x to it. So that says we're going to have 2x plus 1 plus x squared plus 2x minus 1. Combine these, we're going to have x squared plus 4x, and that's it. Okay. So then we're going to say, well, what does it actually equal when x is equal to 2? So what we're going to do is we're going to take this 2 that we see in the problem here, and we're going to substitute it in for our x's right in this portion of it here. And if we do that, we're going to end up with a 2 squared plus 4 times 2, which is going to equal 8. Okay? The other way that we can do this is instead of doing the 2 at the end of the problem, you can actually do the 2 at the beginning of the problem. So that would mean that if I took this 2 and I plugged it into the function, since we're going to be adding, we would have 2 times 2 plus 1, which equals 5. And then here we would have 2 squared plus 2 times 2 minus 1. And that 2 squared plus 2 is going to equal 8 minus 1 is going to equal, 2 squared plus 2 times 2 minus 1 is going to be 4 plus 4, which is 8, minus 1 is going to equal 7. And we said that, I have a mistake here, don't I? Yeah, x squared plus 4x, plus 1 and minus 1. Yeah, I know. All right, hang on, let's just do this. So if I put in 2 times 2 plus 1, that's going to equal a 5. And if I put in 2 squared plus 2 times 2 minus 1, we're going to get 4 plus 4 minus 1, which is 8 minus 1, which is 7. And if I take those and add those together, 5 plus 7 is going to equal 12. What did I do wrong here? Something's wrong. Hang on. F of x is 2x plus 1. G of x is x squared plus 2x minus 1. We get x squared plus 4x. Oh, geez. You can tell it's late and I'm tired because I'm making careless mistakes. So this x squared right here is going to equal a 4, and this 4 times 2 is going to equal 8. 8 plus 4 is going to equal 12. Doy. Sorry. So I'm a human, I make mistakes, right? So it is equal to 12. All right. So when we talk about another way of combining the functions is to form the composition of one with the other. That means we take the one function and we're going to put the other function into it. So when you see this, you're going to see fog. You're going to actually see it quite frequently. When we see this f of g of, what this says is to take g of x, whatever g of x is, and put it into f of x. So that literally says that what we do is we take this and we actually work backwards when we're doing this, that we take the g and we put it into f. If this is a g of f, that would say we take f of x and we put it into g of x. We work backwards. So composition functions look something like this. If we look at this portion right here, to rewrite it, we say let's take the g of x and put it inside of f of x. So you can see right here, instead of having an f of x, we're taking g of x and putting it inside. So if we look at the whole map of this, what's happening is that you follow this map, we're taking x, and whatever x is, you would put it into g of x. Whatever you get at g of x, you're then going to put into, whatever you get for g of x, you're going to then put into f of x and get your value for that. Okay? Shortcut is just saying f of g of x. So what does this look like when we actually put it into function or into operation? So when we say for this first part here, find the composed function f of g of x. F of g of x. Here's what we're doing. When I look at f of x, we have square root of x. When I look at g of x, we have x minus 1. So when we say, let's go ahead and do f of g of x, we are saying, let's take this function right here, that x minus 1, and what we're going to do is we're going to put it into f of x, which means it's going to go right into here in place of this x that we have. And what does that look like when we actually write it out? That's going to be f of g of x is equal to the square root of x minus 1. Okay? And the domain restriction here is still that x minus 1 has to be greater than or equal to 0. So we would say that x has to be greater than or equal to 1. We still have to state that because it's a square root, so we have a domain restriction here. Okay? So the domain for this, f of g of x, is that x has to be greater than or equal to 1. Okay? And that's it. When it says finally f of g of 2 and f of g of 0, here's what it's saying that we're doing. We're going to now evaluate this function when it's equal to 2. So f of, let me get rid of these colors here and just go black for the rest of this. So we do f of g of 2 says that now that we have f of x plugged into g of x, we're going to go ahead and take and evaluate that function when it's 2. So 2 minus 1 equals square root of 1, which is just 1. When we do f of g of 0, and that's going to equal 0 minus 1, what happens here is we get a negative 1, so we get a undefined value. Well, why is this? Well, think about what's happened here. As we said in this problem, the domain of this is restricted, right? That the domain of this says that x has to be greater than or equal to 1. I'm having you try to put in a 0. So we end up with the restriction because we end up with the negative value. We can't have that. Okay? All right, so last question here that we're going to deal with, and these are pretty easy to work through, all of these, okay? But it's just a matter of going from one thing to another. So let's use this to do an example problem, okay? The number n of bacteria in a refrigerated petri dish is given by n of t equals 20t squared minus 80t plus 500. And the domain restriction for this is saying that the time has to be between 2 and 14. I'm sorry, not time. The temperature has to be between 2 and 14 degrees Celsius. When the petri dish is removed from the refrigerator, the temperature of the petri dish is given by the function the temperature in terms of time, and the time is from 0 to 3 hours. So there's that domain restriction on the second problem. So for part A, what it says to do is to find n of t of t. So what this says is to take t of t and plug into n of t. Okay? So that literally says that what we're going to do is we're going to take this right here and we're going to plug it in for this t here, and obviously the t that's over here. So what is this going to look like when I do that substitution? Well, we're going to have t of t, and we're going to plug that in, so it equals 20, and then it's going to be 4t plus 2 squared. All right, yeah, we got squared. Minus 80, and then 4t plus 2. And then don't forget that plus 500. Okay? So again, all we did was we took that 4t plus 2 and we plugged in for each of the t's. Okay, so that's the composition for this. So then for part B, it says, okay, based off of this new function, find the number of bacteria in the petri dish when t is equal to 2. So that means that what we're going to do is we're going to take this function and we're going to put in a 2 for each time we have a t. So we're going to have 4 times 2 plus 500. All right, I'm going to try to do some mental math here. 20 times this will be 8 plus 2, which is 10 squared, minus 80 times this will be 8 plus 2, which is 10, plus 500. So this will be 20 times 100, which is 2,000, minus 800 plus 500. So that means that we're going to have 1,200 plus 500, 1,700 in the petri dish. So 1,700 bacteria. Okay. For part C, it says find the time when the bacteria count reaches 2,000. Now this one's going to require a little bit more work. Okay. So when the bacteria count is going to reach 2,000, and we're asked to find t, we're going to actually solve for t. Okay. And so 2000 is what's going to go on the left side here. And we have 20. And we're going to have 4t plus 2 squared minus 80 times 4t plus 2 plus 500. All right, so now we actually have some work to do here to try to figure all this out, okay? Because ultimately what this is going to be is a quadratic, right? Or we can kind of use Desmos to kind of guide us on some things here, okay? So I'm going to work through it just for the sake of it. We'll get to Desmos in a minute, okay? But let's practice the algebra here. So we're going to have 20 times. This is going to be 16t squared plus, that's going to be 16t plus 4 minus 320t minus 160 plus 500. Okay? We're going to have 2,000 is going to equal 320t squared plus 320t plus 80 minus 320t minus 160 plus 500. All right, let's put some things together here. We can actually get rid of the 320t's here in this problem. And I'm going to move things over. So we have 0 equals 320t squared. The 80 minus 160 plus 500 is going to be negative 80 plus 500. And then we're going to have, that's going to be 420. But we're moving the 2,000 over, so we're going to subtract 2,000 from this, which means we're going to have negative 1580. Okay. So let's solve this. If we move the 1580 over, we're going to have 320t squared. We divide by 320, we get a decimal, so it's like 4.9375 is equal to t squared. We go ahead and take the square root of this. If I can get my calculator to actually do it. I don't have my actual calculator here. All right, hang on, sorry. So we're going to take 4.9375 and we're going to go ahead and take the square root of this, and we're going to get that t is equal to 2.22. That's going to be hours. Okay, so let's make sure that our question actually makes sense, or that our answer for this actually makes sense, okay? When we did the work earlier here, we found out that 1,700 bacteria happened after 2 hours. So it stands to say it's going to require some more time in order for us to get to 2,000 bacteria. And when you look at our answer of t equals 2.22, we do end up with a time that is more than 2, and it gets us to that 2,000, okay? So that is it. That is just some basic work with composition of functions. I believe you guys have done this before, so there shouldn't really be anything too new. But as always, I believe in you. You've got this and you can do it. Don't forget to like and subscribe to my channel. You guys take care and have a wonderful day.